Morning. Welcome to this session. This session, we are going to solve a problem on moment of efforts. How to calculate moment of efforts. So let us see with a simple example. So here goes the question. With reference to the figure given below, determine the moment of a force which is 200 Newton about this point A. Okay, so we need the moment of this force with this point. So this is your moment center. Okay, now let us try extend the line of action of this force. So this is its line of action. Now, according to the definition of moment, I need to draw a perpendicular line from this line of action of the force. So this is the line of action of the force. So if I know this distance, I can calculate moment is equal to 200 into the distance d. Okay. So this is the direct way of solving for moment. Instead, I'll use the components here, so which will make my problem so simple. Okay. So let us see that. See, now I write the components. So this is x component and this is y component of the force. It is easy to write, right? So let me write 200 cos 20 is x component, 200 sin 20 is y component. So instead of taking the 200 directly, I take these two forces. So this is by Varignon's theorem. So you just go back to my previous lectures for the Varignon's theorem application. So Varignon theorem says instead of finding moment from 200 Newton, you can also find moment from the components which will give you the same value. Okay, that's the meaning, right? Yeah, so now you see this is the line of action of the x component. Okay, so if you draw perpendicular, okay, right? So now this distance is the perpendicular distance from the line of action of the force to point A. So I know instead of taking perpendicular distance here, I took it here. Okay, we'll be knowing later. Yeah, so now this is the vertical component and this is your horizontal distance, which is perpendicular distance. Okay, so now if you know these two distances like y and x, okay, your problem is done. Okay, so let us find what is x and what is y. Okay, so see, this is 8 meters given here, 8 meters. So what is x value from this triangle? X is equal to 8 cos 30. Okay, so if you work out, it is going to be 6.928 meters. What is y? It is sine projection. So y is 8 sine 30. So which is going to be 4 meter, half of it. So now these are the perpendicular distances to these components. Okay, now let us write the moment. Moment about A is equal to, first I'll take the x component, which is 200 cos 20 is the force. Okay, what is perpendicular distance? Actually, this is the perpendicular distance. This is also same. Okay, these two are same. So into y. what is the direction? You see, this imaginary line is being rotated clockwise. Clockwise. Okay. So if you take clockwise as positive, okay, so this will become plus. Now take this component, y component, 200 sine 20 into what is the distance? Perpendicular distance. This is the line of action, right? From line of action to moment center, what is the perpendicular distance? This is x. Okay, what is the direction? You see, this imaginary line is being rotated like this, anti-clockwise by the force. Okay, so which means it is minus. Okay, now you substitute what is y? Y is 4. What is x? 6.928 meters. So if you work out, you are going to get 277.885 Newton meter. So this is moment about A, which is clockwise. Okay. So this is how you find moment of a force about a point. Okay. So you can see, instead of directly finding the moment, we have used the components, which is well known Varignon theorem. Okay, so which will make your calculation simple instead of worrying about what is this perpendicular distance. Okay, yeah. So this is the solution, which is now simple application of how you calculate moment of a force about a point. Right. Thank you. We'll be back with some other content.